Hello students and welcome to my channel Maths Hub. So in this video, I'll tell you about how to calculate the particular integral in case of a second and higher order differential equation, and we'll discuss the third case of particular integral in this video. So in the past two videos, I told you about case 1. So let's recapitulate what we have done in the last two videos. So we did the rules to calculate the PI, where particular integral is calculated using the method 1 by FD times Q. So if your FD is just the function D, then we know that 1 by D times Q is equal to integration Q dx. Then we did case 1 when your right hand side function was e to the power ax, and we simply replaced d by a. The second case was when the right hand side function was a function in trigonometry, that is either sine or cos. So in that case we were replacing d square with minus a square, and the case failure was in above two cases, that if the denominator was becoming 0, then we were multiplying the numerator by x and we were taking the derivative of the denominator. So now let us consider third case. So in the third case we have sine hyperbolic or cos hyperbolic functions. So it is just the opposite of sine and cos. So in sine cos we were replacing d square with minus a square. Now we will be replacing d square with plus a square, right? And then the same thing, that f of a square should not be equal to 0. So in case f of a square becomes equal to 0, so then we have to proceed by the same method that we were dealing in case failure, right? So now let us try this following exercise. We need to solve the particular integral in this case. So let us first find out the symbolic form of this equation. So this is d square plus 2d plus 2 into y is equal to sine hyperbolic x. So from here we get y is equal to 1 by d square plus 2d plus 2 into sine hyperbolic x. So according to the rule, how we will replace it? We will replace d square with plus 2 square, right? So it's not plus 2 square. Here when you compare it with sine hyperbolic a square, a is 1 over here, right? So now let us replace it. So we will get d square is 1. So 1 plus 2 becomes 3. So we will get 2d plus 3 into sine hyperbolic x. So as I told you in the previous video, that whenever we are left with d in the denominator, we need to finish it. So to make from convert d to d square, we have to multiply with its conjugate. So we multiply with its conjugate pair, so it is 2d minus 3. So we will get 2d minus 3 upon 2d plus 3 into 2d minus 3 is 4d square minus 9 into sine hyperbolic x. So again we need to replace d square with 1 square, and that will get converted into 2d minus 3 upon minus 4 minus 9, that is minus 5 sine hyperbolic x, right? So now further this is, you can open up the brackets. So this is minus 2 by 5 d of sine hyperbolic x, and then we will get 3 by 5 of sine hyperbolic x, right? So those of you who have confusion in this topic of hyperbolic functions, what is cos hyperbolic x? It is e to the power x plus e to the power minus x divided by 2. And what is sine hyperbolic x? Sine hyperbolic x is e to the power x minus e to the power minus x divided by 2. Now what about their derivatives? Derivative of cos hyperbolic x is, you'll take the derivative of this term, so you'll get half e to the power x minus e to the power minus x. So that means this is basically sine hyperbolic x. And when you take the derivative of sine hyperbolic x, what will you get? It is 1 by 2 is constant. You will get e to the power x plus e to the power minus x. So that means derivative of sine hyperbolic x is cos hyperbolic x, right? So in that case, this term will become minus 2 by 5 So derivative of sine hyperbolic x will be cos hyperbolic x plus 3 by 5 sine hyperbolic x. So that comes out to be your particular solution, right? So let us try to do one more problem. So we need to find out the particular integral for this term. So let's write down what is the particular solution. So it is 1 by d square plus 4d plus 5 into minus 2 times cos hyperbolic x. So according to the rule, we will replace d square with again 1 square. So I can take out minus 2 common from here. I will replace d square with 1. I'll get 4d plus 6 into cos hyperbolic x. So I can take out 2 common, 2 will get cancelled, and I'll finally get 1 by 2d plus 3 into cos hyperbolic x. So again, the denominator d can be finished off by multiplying with its conjugate, and the conjugate term becomes 2d minus 3 upon 2d minus 3. So that turns out to be minus of 2d minus 3 divided by 4d square minus 9 into cos hyperbolic x. So again we are going to replace d square with 1 square. So that becomes minus 2d minus 3 divided by 4 minus 9 is minus 5, and we are left with cos hyperbolic x. So minus sign gets cancelled. When you open up the brackets, you will get 2 by 5 times derivative of cos hyperbolic x minus 3 by 5 times cos hyperbolic x. So that turns out to be 2 by 5 sine hyperbolic x minus 3 by 5 cos hyperbolic x, right? So that comes out to be the answer. So I hope you understood this rule. So thank you so much for listening. So if you like the video, do hit the like button, and those of you who have not subscribed my channel, do subscribe my channel to get the latest updated video, and believe in yourself and you will be able to succeed. Thank you so much.